everyone! Have you ever heard of carbohydrate analysis? If not, let's keep on watching. Carbohydrates are one of the most important components in many foods since it is source of both energy and dietary fiber, and that they can enhance the sweetness, visual appeal, and texture quality of many foods. Still, many people are unaware how much science is involved in the food they consume. What exactly is a carbohydrate? Carbohydrates may present as isolated molecules or may be physically or chemically bound to other molecules. Individual molecules can be categorized as monosaccharides, oligosaccharides, or polysaccharides depending on the number of monomers contained in them. Glycoproteins are molecules in which carbohydrates are covalently bound to proteins, while glycolipids are molecules in which carbohydrates are covalently bound to lipids. Humans can digest some carbohydrates, which are an important source of energy. However, some carbohydrates are indigestible and do not provide energy. Carbohydrate analysis is very important in food science because of the important role of polysaccharide as macronutrients, as major constituents of dietary fiber, and as structural components of foods that contribute to the properties of texture and food additive. Carbohydrate analysis is important for a variety of reasons. First, it is important for nutritional labeling. This serves as a way to inform customers about the nutritional value of food. The second is for standards of identity. Food must be produced in accordance with legal requirements. It also helps protect consumers and promotes honesty and fair dealing. Third is for food quality. The type and concentration of carbohydrates available influences the physical-chemical characteristics of the food, including sweetness, appearance, stability, and texture. By analyzing its component elements, manufacturers can precisely control the taste, appearance, and quality of food. Lastly is for food processing, because the effectiveness of some food processing processes depends on the type and concentration of carbohydrates available. There are many methods for analyzing carbohydrates, but today we are going to focus on two methods, which are Munsell-Walker method and Antone method. Firstly, the Munsell-Walker method, which is categorized under gravimetric method. The principles of this method are: the carbohydrates oxidize with the presence of heat and an excess of copper sulfate and alkali citrate under carefully controlled conditions. It leads to the formation of copper oxide precipitation. Then, the amount of precipitation formed is directly proportional to the concentration of reducing sugar in the sample. The chemical equation involved is reducing sugar plus copper to ion plus base will produce oxidized sugar and copper peroxide in form of precipitate. In all, the concentration of precipitation can be determined by either gravimetric method that involves filtration, drying, and weighing, or titrimetric method in which dissolving the precipitation and titrate with suitable indicator. Next method is Antone method. This method is a part of the calorimetric method. So, the principle involved are: the carbohydrates in samples react with the Antone reagent, in which the reagent is a mixture of Antone and concentrated sulfuric acid. Then, the reaction between carbohydrates and sulfuric acid produces furfural, and the product reacts with Antone to yield blue-green color complex under an acidic condition after boiled for 10 minutes. The solution then being cool and its absorbance is measured at 620 nanometer. The absorbance and amount of sugar present is interdependent. It is a non-stoichiometric, thus the use of calibration curve is unnecessary. Now, let's take a look at the advantages and disadvantages of both methods. Munsell-Walker method advantages is to determine gravimetrically electrolytic deposition and titrimetrically, which is more accurate and reproducible than lane A9. The concentration of precipitate present can be determined gravimetrically or titrimetrically, as the amount of precipitate formed is directly related to the concentration of reducing sugars in the initial sample. Meanwhile, the disadvantages are similar to lane A9 method. The results depend on few factors such as the precise reaction times, temperatures, and reagent concentration used, and so these parameters must be carefully controlled. Next, it cannot distinguish between different types of reducing sugar. Then, it cannot directly determine the concentration of non-reducing sugars, while it is susceptible to interference from other types of molecules that act as reducing agents. Next is advantages for Antone method. It determines both reducing and non-reducing sugars because of the presence of the strongly oxidized sulfuric acid. It is non-stoichiometric and therefore it is necessary to prepare a calibration curve using a series of standards of known carbohydrate concentration. As for the disadvantages, Antone test gives a negative result in samples that are carbohydrates like D-glucosephenyloxazone and D-glucosephenyloxatriol but do not form furfural or hydroxyfurfural in the dehydration step. That's all from us. Thank you for watching.